rule 3 in this question, or case 3 of the exact differential equation, right? Alright, so now for this rule 3, we have a very special form. Whenever you can express the equation and you have your m to be equal to y f1 xy, then plus n equal to x f2 xy. Whenever you can express the equation like this, then you're going to take your integrating factor to be equal to 1 over m multiplied by x minus n multiplied by y, right? Whenever you can express your equation in this form above, right? So I'm going to write an equation now so we see exactly how that plays off and how we can solve question using this form. So y xy plus we have 2x squared y squared dx plus x into bracket xy minus x square y square dy is equal to 0. So now we can see that this question is in this form above, right? So we have our y, we have our f1, and then we have our dx, and then on the same thing for here we have our x and we have our f2. So we can see it's in this form, so that means we can use this method, right? So now some questions that they will give you, they will not make it as easy as this, right, where you have your y already substituted outside, right? So one thing you can do is that whenever you're given a question and you're not sure, what you can quickly do is just check, can you factorize y out, can you factorize x out if it's not explicitly given in the question. Alright, so now for this question, now what I can see from this equation is that I have xy x squared y squared xy x squared y squared in both of the brackets. What I can do is I can divide everything by xy so that I can simplify the equation, right? A simplified equation is always better to solve. Now, not in all cases you'll be able to divide through by xy, right? Just check, do you have xy in all of them? Can you factorize xy out? If you can, then you can divide through by xy, right? So we're going to have y, and I'm going to be factorizing xy out. So I'm going to have 1 plus 2xy, then I have dx plus x, I have xy, then I have 1 minus xy dy is equal to 0, right? This way it makes it easier for us to solve. So here I can divide through by xy, so xy will cancel, xy will cancel. So here I'm going to have y into the bracket of 1 plus 2xy, then I have my dx plus x 1 minus xy dy is equal to 0. So now what I'm going to do now, because I'm looking for this integrating factor, I'm going to find mx, right? That's m times x. So let me just multiply this in the bracket. So I have y plus 2xy squared dx plus x minus x squared y, then I have dy equals to 0, right? So I'm going to have my m times x, and this is going to be equal to xy plus 2x squared y squared. Then I'm going to have my n times y, which is going to be equal to xy plus, minus x squared y squared. Now I'm going to find my integrating factor using the formula 1 over mx, which is going to be xy plus 2x squared y squared minus xy, that's going to be minus, right? So what do we have? Okay, we have minus, negative sign. So this is going to be minus times minus, which is going to be plus x squared y squared. Have this, and now we are going to simplify. So we're going to have our integrating factor to be equal to, this is going to cancel out this. It's going to be 1 over 3x squared y squared. So we have this, and now what we're going to do now, just like case 1 and 2, we're going to use our integrating factor to multiply the entire equation. So we're going to have 1 over 3x squared y squared multiplied by y plus 2xy squared dx plus 1 over 3x squared y squared multiplied by x minus x squared y dy is equal to 0. So now we're going to multiply. So we're going to have 1 over 3x squared y, 1 over 3x squared y plus 2 over 2 over 3x. Yes, we're going to have 2 over 3x, and then close our bracket dx, plus here we're going to have 1 over 3xy squared, and then we're going to have minus 1 over 3 1 over 3y. Yeah, we're going to have 1 over 3y, then we're going to have the y is equal to 0, and just like your normal base form, you're going to take the integral of m dx plus the integral of n dy, but you're going to be only be using the value of n that has only y as its variable. So let me clean this side so that we have enough space to solve the rest of the question. Alright, so now for m, we're going to have the integral of m, which is going to be, so I'm going to rewrite this putting the constants on one side, right? Because we're integrating respect to x, we're taking y to be a constant, then multiplied by 1 over x squared dx plus the integral of 2 over 3 times 1 over x dx plus the integral here, the only value of n that has only y is this one, so it's going to be negative 1 over 3 times 1 over y dy is equal to c. So now we're going to take 1 over 3y as a constant and integrate 1 over x squared, which is going to be x raised to the power of negative 2, and then on integrating that is going to be x to the power of negative 1 over minus 1, which is going to be negative 1 over 3y x or 3xy. Then we're going to have plus 2 over 3 ln x. Then we're going to have minus 1 over 3 ln y is equal to c. And now we can see that we have 3 as the denominator in um, every single coefficient. So we're going to multiply through by 3. So we're going to have negative 1 over xy plus 2 ln x minus ln y is equal to c. And when we have a negative sign in between logarithms, we can go ahead and divide them. So we're going to have negative 1 over xy, then we're going to have plus ln x squared over y, right? Because these two will come here to become the power of x. So we're going to have x squared over y is equal to c, and then we can take this one to this side to eliminate the negative sign. So we're going to have the natural log of x squared over y is equal to c plus 1 over xy. We can even multiply through by xy. So we're going to have xy ln x squared over y is equal to c times xy plus 1. So the answer can be like this, it can be like this, and even from this part of the question, you can even take the exponents of both sides. So you can have your answer in a lot of different ways, just depending on the answers in the option. And that is all we're going to do on case 3.